Force is dependent on time. Often forces that are acting on particles are not constant and can be defined in terms of time. In these situations, it's possible to use Newton's second law of motion, F equals ma, to find the acceleration of the particle defined in terms of time, and so velocity and displacement from this. So, in this example, a force of 2t minus 1 newtons acts on a particle of mass 0.5 kilograms. At t equals 1 second, the particle is travelling at 1 meter a second and is at the origin. Find the velocity and the displacement when t equals 3 seconds. So the thing to note with this question is that we're looking to find displacement and velocity. And what we've experienced so far is that displacement and velocity is linked to acceleration. So if we consider this particle, here's my particle, has a mass of 0.5 g, and there's a force of 2t minus 1 newtons acting on it. So if I was to resolve horizontally using Newton's second law, F equals ma, then I form the equation that 2t minus 1 equals 0.5 a. And so now I've formed an equation that involves the acceleration. This can link then to the velocity and displacement. So all that's left at this point is if I multiply both sides of this equation by 2, I get the acceleration is 4t plus 2. And so now from this point onwards, we continue the question as we had done previously. So let's continue on and find the velocity and displacement when t equals 3 seconds. So at this point, we know that a equals 4t plus 2. If we go back to the information in the question, sorry, this shouldn't be a plus, let's get rid of this and change it to a minus. My mistake there. At time t equals 1, the velocity is 1 and the displacement is 0. So let's just correct this so that it is in fact a minus. So at t equals 1, the velocity was 1 and the displacement s equals 0 since it's at the origin. So now to find the velocity, I'm going to integrate 4t minus 2 with respect to t. So we get the velocity, t integrates to t squared, divided by 2, so we get 2t squared. Integrate the 2 becomes 2t, and then plus the constant of integration. We're now going to find the constant of integration using v equals 1, t equals 1. So 1 is equal to 2 lots of 1 squared minus 2 lots of 1 plus c. And if you work through this, we get 2 minus 2, so c must be equal to 1. And so this was our general solution to our differential equation. Then our particular solution to our differential equation is 2t squared minus 2t plus 1. And at this point, we can actually find the velocity at t equals 3. So I'm just going to substitute t equals 3 into the equation. So I've got v equals 2 lots of 3 squared minus 2 lots of 3 plus 1. And so we get v equals 18 minus 6, which is 12, plus 1, which is 13 meters a second. Okay then, so continuing on, now we need to find the displacement. The displacement is found by integrating the velocity. So the displacement is the integral of 2t squared minus 2t plus 1 integrated with respect to t. When I integrate that with respect to t, I get that the displacement s is equal to 2. T squared integrates to t cubed, and I'm going to divide by 3, so I can't do anything further really there other than leave it as 2/3 of t cubed, minus integrate the t, that becomes t squared, and divide the 2 by 2, it disappears, and then integrate 1, we get t. And then again plus a constant of integration. So this is again our general solution. So now find a particular solution using that t equals 1, v equals 0. So we get 0 is equal to 2/3 of 1 cubed minus 1 squared plus 1 plus c. So the minus 1 and the plus 1 cancel each other out, so I get left with 2/3. If we rearrange that, we get c is equal to minus 2/3. And so then just finishing off, our particular solution for this equation is that it's 2/3 t cubed minus t squared plus t, and then it's minus 2/3 at the end here. Let's just tidy this up slightly. And so we're just going to substitute in that t is equal to 3. So we get that s is equal to 2/3 of t cubed. Sorry, let's adjust that. It should be 3 cubed, obviously. 2/3 of 3 cubed minus 3 squared plus 3 minus 2/3. And so for this one, just for ease, I'm going to type that out on a calculator just to save a little bit of time. So we get 2/3 times 3 cubed minus 3 squared plus 3 minus 2/3. And this comes out as an answer of 34/3 meters. Okay, so what changed in that question? Well, nothing really changed. You can see from this page you're working out that actually the methods used in the of calculus used for linking acceleration, velocity and displacement remain the same. All that changed was this initial step at the beginning here, linking the idea that we've got a variable force over time. We just resolve with that using Newton's second law and linking it to acceleration, so that it gives me an equation for acceleration to work with. Okay, I hope that all made sense and you was able to understand it.